Hello. In the video magnetic levitation, magnetic spin, in response to gravity, I gave the information of spinning a magnet at 144 hertz. And I mentioned that I have very strong magnets and weaker magnets. So one thing that I would like to add here at this point is the a little bit of the equation of the magnet overcoming the Earth's gravity has to do with the diameter of the magnet and the magnetic field. Everybody's probably looking at the magnets on the fridge and thinking to themselves, well, I'm going to spin this magnet, or maybe they go to the store, or maybe they go on Amazon and they buy neodymium magnets and they spin and they spin them and they spin them and they say, well, this isn't working. So what happens is the base equation that I work with excuse me, is actually based on a magnetic field that is 1 meter in diameter. So that's the very first thing to come across. Now you're going to say 1 meter in diameter. Where do you get a magnet that's 1 meter in diameter? You don't. You make it. Okay. How do you make it? How do you make a magnet? Okay, I am saying you make a magnetic field. I referred to before that you're going to charge the magnets, or you charge the ferrous material with microvoltage to they get the atoms lined up. You have to understand what makes a magnetic field. Go to the electricity or the electrician's guidebook. When they're measuring a wire, they're using an ohms meter. They put the meter around the wire. Well, what they're doing is they're measuring the magnetic field around the wire. Okay, you have to understand this first. You can't just say, oh, well, you know, all these equations about, oh, we're going to work with the magnetic field and we're going to work with 0 point energy or 0 point energy to get zero gravity or reverse gravity. No, you have to excuse me, you have to understand the magnetic field first. So I'm sorry, you want bought these neodymium magnets. And I did say that I have worked with a lot of very strong magnets. I have getting the neodymium magnets up to probably like a N52, having 1,000 pound pole pressure. And I have got them to levitate themselves, spinning around a steel rod. But the magnetic field is more than that magnet. Okay, the magnetic field itself is the field around the electrical. So let's go back to a basic principle. I was trying to teach the state the State Department in my state about this. Department of Commerce and the people associated with that. Excuse me. Made a mistake and drunk some hot chocolate this morning. So anyway, you have to make a magnetic field. To make a magnetic field, you have to have an electrical current. Now, I'm not talking about electrical current of the 12240 that you're plugging into your house outlet. No. We're not dealing with AC. We're dealing with DC, and we're dealing with current that, at the very best, would cause your hair to stand up on end, kind of like static electricity. You have to have an electrical current to create a magnetic field, you have to have a magnetic field to create an electrical current. Now you have to understand how the magnetic field responds to metals. There's been a lot of talk now about and some people have built machines where the magnetic field or the magnets on a plate are responding to any aluminum plate, and that's really good. But it's kind of like wiring your house with aluminum wiring. It'll work, not very good. And so we have Lenz's law. Look it up, L-E-N-Z, Lenz's law. It is the way that the magnetic field responds to copper. And also we have electromagnetic induction. Electromagnetic induction is when you have, put this over here, you have a magnet, and you have copper wire. Okay, fingers here, copper wire. And so the magnet is going to go around and pass through or pass by the copper wire. With the magnet itself, the magnetic field extends beyond that magnet. The copper wire passes through that magnetic field. Now the trick here is what speed does it need to pass through it? Well, instead of saying hertz, I'm going to say it needs to pass through it at greater than 20 linear miles an hour, or greater than roughly 7,000 RPM for people that's spinning the magnet. And you need to understand how to connect the magnets together with the copper to create the magnetic field. You can do it with aluminum, but it's going to be weaker. And that's one of the reasons why they haven't been able to be successful with this. And I will be putting together a diagram later on to show you how to make a magnetic field by combining excuse me, by combining small magnets in a series with copper. You're going to be doing both creating electromagnetic induction, and you're going to be using the Lenz's law to create it's called photonic energy, where the magnet and the copper produces light energy. Okay, that light energy is going to be producing at a quantum level the same energy as thundercloud or lightning bolt, and it will change the atmospheric pressure. It will change the barometric pressure around the area where the copper and the magnetic field is passing through. Electricians know this, and those that study magnetism, those that study the various different layers of the atmosphere and how they change to pressure and so on, they all understand this. So your magnetic field, it is based on being 1 meter across in diameter. And then you can say, all right, now how fast does it have to move? Okay, now we're going to say 1 meter in diameter, and you say, but there's no such thing as 1 meter in diameter. This is where you have to be able to understand the difference between the ratio of the diameter and the RPM or the hertz that you're working with. And certainly 144 hertz, yeah, that's a good place to get started. Now, if you have the power to turn a magnetic field at 144 hertz, And if you can do it with, if you can get a magnetic field going, that's a meter across, by the way, I do have the patent on this technology. So, and my attorney is watching the world. I gave them permission to watch everything, everybody. It doesn't matter if they're military or not military. That if they get close to this, then he's gonna let me know, and then we'll have a discussion from there. So anyway, 1 meter in diameter. Our puppy. Hello, Sky. Big. Yeah, let me show you. Let me show you our puppy. There's a puppy. There's a puppy. And you saw a mess over there. Anyway, I've been doing a lot of work here in the front room. So, 1 meter in diameter. Nobody is going to be doing a 1 meter in diameter magnetic field except for maybe Crazy Moi. I have done. I have made magnetic fields that were a third of a meter in diameter, and I will be showing that to you a little bit later, where at the proper hertz or RPM, it does change, and it's gravitational field. It does change that, and so. Also, there's several alsos here. You need to understand the pretend law of centrifugal force. I've seen some of these where they're doing like the gravitron, and they make the gravitron and they turn it on and it explodes. It's because you have to understand the material that you're working with. You have to understand the tensile strength of the material that you're putting the magnet into, because if you get a 1 pound magnet and you spin it, the centrifugal force of that 1 pound magnet will translate into over 5 tons of pressure. And if you haven't already looked at the material that you're attaching it to, and you have already been able to say, okay, engineering, you have to have 30% greater strength than what's actually going to be. So look at the tensile strength of the material and make sure that it's 30% above that force that your magnet is going to be turned into. And if it can't handle it, you better not do it, because it'll turn into a grenade. It will turn into a grenade. I have done this so many times, putting holes in walls and stuff, that when your new magnet, these little tiny magnets bolted around, circle on the plate of various different types, when they hit that speed, you're going to have a grenade there. You have to know the material. Get the material. You need to find the material and find out from the center of it, measure it out, do the equation for the centrifugal force, for the speed, for your mass, find out what pressure it's going to turn into, because it will rip that plate apart. It doesn't matter if it's polyurethane, if it's aluminum, if it's steel. It'll rip that plate apart if you don't have the right materials, and it can hurt you really bad. So make sure you know what you're working with. And there's a whole lot of information to put out on this, and this is going to be kind of the carrot to get us going from here. And I have been trying to teach NASA this for 4 years, and they don't get it. I've been trying to teach DARPA this, and they don't get it. I've been trying to teach the Department of Defense, and they don't get it. Now, if you listen and you stick with me, I'll teach this to you, and you will have to work with me, and we can help people to understand how to get their vehicle flying. Thanks, and please subscribe.